Hi there, students. Welcome back. This is Mrs. Brunk again, and today we're going to be continuing our work on transformations in the coordinate plane. And so let's recap what we've done so far. In the first lesson, we talked about translating, and the main focus was on translating by vectors in the coordinate plane. In the second lesson, we talked about reflecting over specific lines in the coordinate plane, like the x-axis, the y-axis, the line that cuts through the first and third quadrants, which is the line y equals x, and then the one going through the second and fourth quadrants, which would be the line y equals negative x. So we've covered reflections, we've covered translations, and today we're going to focus on rotations. So our learning goals will be to draw rotations 90 degrees, 180 degrees, or 270 degrees of a shape in the coordinate plane. And a rotation is another way to say, it's kind of the fancy way to say a turn. So one thing I always think about when I think of rotations is like an old clock, analog clock with the hands on it. And the tip of each of those hands rotates around the clock, and depending on where it lands, it tells you the time. And those two hands are anchored at a center of the clock, like there's a little pin in the center of the clock, and that on a clock is the center of rotation. So anytime we have a rotation, just like when we had a reflection, we had to have a line of reflection. When we have a rotation, we have to have a point that the figure is rotating about. So then that's called the center of rotation. And a rotation is a transformation about point P, the center of rotation, such that the following things are true. Every point and its image are the same distance from P. So each of the pre-image and the image are the same distance away from the center of the rotation, and all angles with vertex P formed by a point and its image have the same measure. This angle measure is called the angle of rotation. So just like we had rules for the translations and rules for the reflections, we have rules to apply to coordinates for our rotations. So going back to our clock idea, if the hand is turning in the correct direction, the way that it's supposed to be going, it's called clockwise direction. Well, a clockwise rotation is actually considered to be a negative rotation, a negative degree, and that's because you're going down relative to, say, the x-axis. So like if you had like an x-axis, this in the coordinate plane. So we consider the ones that are going in a clockwise direction, we call those negative, and the ones that are going in a counterclockwise direction, we call those positive. So if you were actually told to rotate something, say, negative 90 degrees, it would mean 90 degrees in the clockwise direction. And if it was a positive, then it would mean to go the counterclockwise direction. So the first rule we're going to look at is the rule to rotate a point, and therefore if we rotate all of the points of a figure, then the whole figure will rotate 90 degrees counterclockwise. So that would be in a positive direction, going again like this way around, like that. That's counterclockwise. If we want to rotate 90 degrees, this is the rule that would do it. It would take the point x, y, whatever that coordinate might be, and it maps it onto negative y, comma, x. So what's happening here is the coordinates switch around and then make the first coordinate the opposite of what it was to begin with. So again, we're going to switch and change the first. Now if you think about rotating something counterclockwise 90 degrees, if instead you were going the other way around, you would get to the exact same place going 270 degrees. See, for instance, say I took my little clock hand and I rotated it. And say I rotated it 90 degrees. This looks like about 90 degrees counterclockwise. Then I would get there going 90 degrees counterclockwise, but I could also get there by going clockwise 270 degrees. So that rule will not only rotate counterclockwise 90, it's the same as going 270 clockwise as well. So that's why we've added that here next to it. So that's get you to the same spot. Now the next rule is rotating 180 degrees. Now it doesn't matter which direction you're going there, because 180 degrees takes you halfway around, and you'd be at the same exact place whichever direction you go. So they didn't indicate counterclockwise or clockwise here. So to rotate 180 degrees, all that you have to do is change the sign on both. So it takes the X and makes it its opposite, takes the Y and makes it its opposite, and that will rotate 180 degrees. Now if we wanted to go 270 degrees in the counterclockwise direction, so we want to go so that we're going 270 counterclockwise or 90 degrees clockwise, then that rule looks a lot like the 90 degree counterclockwise rule, except for that this time we switch the coordinates around and we make the second one the opposite. So see how the X is now a negative, or it's saying it's the opposite? So this time we're going to change up that rule that we wrote for the first one a little bit. We're going to switch the coordinates, but then change the sign on the second. And finally, the easy one, 360 degrees. And you know, if you turn around 360 degrees, you're right back where you started from. So the coordinates stay exactly the same. XY maps onto XY. So no change needed when you're going 360 degrees. So now that we know the rules, let's try to put them into practice. So example 1 says to draw the image of the figure under the given rotation, and it indicates that each of these angles that's listed is counterclockwise. So they want us to choose the rule for counterclockwise 270, and let's take a look at what that rule is. So that's this one right here. It's going to take the x, y coordinates and map them onto y, comma, opposite of x. So remember we made a little note on this one that was switch and change the sign on the second coordinate. So that's all we have to do, is we just have to write down this rule. We're going to make the x the y, and then we're going to take what was the x and make it the opposite. And so this is the rule we're going to apply. So first of all, we want to identify these coordinates that we have here. So let's list out the coordinates of the original. So A is at 0, 2. B is at 1, 1, 2, 3, 4, 1, 1, comma 4. C is at 4, 2. And D is at 3, 1. So now to get my new coordinates, what I have to do is reverse the order, and then I have to change the sign on the second coordinate. So this is going to be my A prime, and so when I reverse them, it puts the 2 first, and it makes the second coordinate be 0, and then take the opposite of that. Well, you can't really take the opposite of 0, so it's going to stay 0. The next one is going to, when I reverse them, the 4 now goes in the first position, the 1 goes to the second position and changes sign. In C, reverse them, so the 2 becomes the x now, and what was the x now? If I take the opposite of it, becomes the y. And then for D, reverse them, so now the 1 becomes the x, and that 3, if I take the opposite, becomes the y. So these are my new coordinates. I'm going to plot those out, and that will give me my new figure. So instead of 0, 2, it's at 2, 0, so this is the A prime. 4, negative 1, so that's the B prime. 2, negative 4, that's the C prime right here. And 1, negative 3, that's the D prime. And when I connect them to make my figure, oops, that's not good. This is what my figure looks like. Now, sometimes that's hard to tell. I mean, it definitely looks like it's a rotation, but as far as the 270 degrees goes, so what you can do is you can pick a pair of points, and it doesn't really matter which one. So let's say I pick A, and then its image, and I'm going to connect them back to the origin. Okay, now these just happen to be on the axis, And so, that's, but I'll show it with another one. But when you connect back to the origin, which is always the center of rotation for the coordinate plane, you can see that this rotation either went this way, which would be clockwise 90, or it must have gone around this way, which is 270 degrees. Now, the reason why I know that's 270 degrees is because the entire way around a circle would be 360. So if going one way is 90, the other way would be the rest of 360, which is 270 degrees. And so we can definitely see that this is a rotation 270 degrees in the counterclockwise direction. So really all you need to be able to do is identify the rule that you're going to use, the coordinate rule, apply the rule to the coordinates, and then plot the new points and connect them to get your new rotated figure. Okay, so the next one is to rotate 180 degrees. And again, the direction said counterclockwise. But as it turns out, 180 degrees is halfway around, so it doesn't really matter which direction you go. And here's that 180 degrees. The rule is to just change the sign on both. See, it's right there. Right? Change the sign on both coordinates. So you're going to make each of the coordinates the opposite of what it was to begin with. So again, we're going to identify the initial coordinates. So we've got L and M and K. And M, L is at 4, -1. Let's see, M is at 1, -4. And K is at 2, -1. So all I have to do to get my new coordinates is just change the sign on everything. So this is definitely the easiest rotation rule, just make everything the opposite. So what was 4 is now -4, what was -1 becomes 1, what was 1 becomes -1, what was -4 becomes 4, and what was 2 becomes -2, and what was -1 becomes 1. So those are my new coordinates. I'm just going to plot those out and connect them to get my rotation. So left 4 and up 1 is the first coordinate, so this is my L prime. Then left 1 and up 4 is my second coordinate, that's M prime. And then left 2 and up 1, this is my K prime. And I'm just going to quick connect them. And you can see that triangle looks identical to that original one, except for it's rotated. And to look at that rotation and make sure that it's 180 degrees, you could take a point, say K and its image, connect back to the origin, and you can see that if you look at that angle right here that goes from K to K prime, that's definitely half the way around the coordinate plane, or half around the circle. That's 180 degree rotation. And it doesn't really matter. I mean, I'm showing the arrow going counterclockwise because that's what they said, but you can see that going the other way would be exactly the same. So we're going to go ahead and try one more together, and then we'll have one as a you try question. So this next one says to take PQR and to rotate it 90 degrees. So first I'm going to write down the coordinates for P, Q, and R. So P, its coordinate right here is at 2, 1. I've got Q, which is at 4, 1. And I've got R, which is at 4, -3. So let's go back and look at the rule. So the rule for 90 degrees, and this is supposed to be counterclockwise because the directions still hold for this question. So the one we're looking at now is 90 degrees counterclockwise, and that's this first one. And what that one says is reverse the coordinates and change the sign on the first one. So this time we're going to take those coordinates and we're going to turn them around, and then we're going to change the sign on the first one. So let's write that down. The rule is switch them and change the sign on the first one. So -y, x. So reverse the coordinates. So that's the first thing I'm going to do is just reverse them, and then I'll fix the sign. So if I take P and reverse them, I now have 1, 2, but then I want to make the first coordinate the opposite sign. I'm going to reverse the coordinates for Q, so that's going to make the 1 go first and then the 4, but then change the sign on the first one. and then reverse the coordinates for r, make that -3 and 4, but now I'm going to change the sign on the first one, so make it a +3 now. So here's our new coordinates, and of course these are called like P prime and Q prime and so on, so when we plot them. So if we plot these, that should rotate at 90 degrees in the counterclockwise direction. So let's see, -1, 2 would put me right here for P prime, and -1, 4. So that's our Q prime. And then 3, 4, which puts us up here, and that's R prime. And when I connect them to make my triangle, oops, that was supposed to be, I went a little bit over that point. There we go. And again, it's a good idea to check and make sure that that looks like it's 90 degrees in the counterclockwise direction. So what we want to do is just pick a coordinate and its image, oops. So you can do whichever one. I usually like to pick the one that's closest to the origin, but you can do whatever one you want. And I'm going to just connect back to the origin. So from R to R prime, oops, that's not R prime. That's supposed to be, I labeled that one wrong. That second point was, okay, which would have definitely not looked like a rotation. That one was supposed to be 2, let's see, -1, 2 was P prime. Oh, that did label it. It's just way over here. Okay, so we'll go ahead and maybe connect the P's to the origin. So I just take the P and go back to the origin with it. And then take the P prime and go back to the origin with it. And you can see that angle that I just created. The smaller of the two angles is right here. And that one definitely looks like a 90-degree angle, and it's going in the counterclockwise direction. So we can confirm that we actually did rotate it the way we were supposed to. So again, you could have really done that with any of the points. I could have done it with, I could have connected R back to the origin and then R prime, Q and Q prime back to the origin. Either way, you'd see that angle is repeated between every pair of coordinates that are corresponding coordinates. And we're going to go ahead and designate this next one to be a U-try question. And it's actually one of the rules we've already used. It's the 270. So if you want to look back at A, example A, that should be a good reference. So you can see that this is the rule right here. And so we're just going to repeat that rule for this example. It's going to be y, comma, -x. So it's reverse the coordinates and change the sign on the second one. So it's basically the opposite rule that we just used on this last one, where we reversed the coordinates and we changed the sign on the first. Now we're going to reverse the coordinates and change the sign on the second. So first of all, list out for your U-try the coordinates of the original points, and then apply this rule to the new ones and plot them. And we'll either check them in class if we are doing class in person, or we'll have you submit your answers in some way, which I will let you know. So go ahead, pause the video now, give example D a try, and then once you get your answers, turn back in, and we're going to wrap up the lesson. Okay, so thanks for giving that one a try. Hopefully you were successful in rotating 270 degrees counterclockwise. Now in our final learning goal, we're going to take a look at how can we tell if two figures have clearly been rotated. How can we tell what that angle of rotation is? And so the strategy that we use to check our rotations in the coordinate plane is really the same strategy we're going to use here. We would take a point and its image and connect them both back to the origin, which was the center of rotation. And we could see that it was either 90 or 270 or whatever. Same thing here. So what we're going to do is take and identify a point on the original. We're going to connect it to the center of rotation. So we can see here that the center of rotation is the point P. And so I'm going to connect back to P. And then I'm going to connect the image of Q to P as well. And that is going to actually show me how far this coordinate has rotated. Well, The other coordinates have rotated the same amount, so you really just need to do it with one pair. And so I can tell that either this has rotated from the original, which is here, starts here, and rotated this way. So that's either a clockwise rotation of this angle, or it could be rotating this way, counterclockwise. Now usually when we give the angle of rotation when it's not in the coordinate plane, we just go the shortest route. So this one is going to be a a clockwise one, which sometimes you'll see them identify that as a negative angle, but you could also just list it as the angle and then say clockwise. So if I had a protractor that I could use on this video system or this interactive whiteboard, I could put that protractor down, and I mean this looks maybe to be about, let's see, so we're going to estimate. Hopefully you'll be able to use the protractor in the online homework. So this is an estimate. It's about 120 degrees, and since it's going in the clockwise direction, I'd either write clockwise or I would write negative 120 degrees. And again, I didn't have a protractor that I could use on this interactive whiteboard, but I was kind of guesstimating. It looks like maybe 120. That's not a bad guess. So let's try a couple more. So we'll try one and then have you, hopefully you have your protractor handy and you can do this, or again on the online assignment there is one in the toolbox that you can use on the computer screen. So let's try one more and then leave one for you to try. So choose a pair of points that you want to identify. So A and its image, I'm going to use A again, and then A prime and its image. Oop. I keep going to the wrong spot. Well, shoot. Now that angle looks really close to 90 degrees, but it looks just shy of it. So if we're going this way, we're going counterclockwise, and it looks to be maybe about, I'd say, 85 degrees. And again, we want to be more accurate, so if we had a protractor, that would be ideal to be able to put on here and check that. But it looks like 85 degrees in the counterclockwise direction. And so you could abbreviate it with counter if you want to, but counterclockwise or a positive 85 degrees. Again, alternatively, you could say it's going this way around, but chances are you're going to go the short route. So going the other way around would just be 360 degrees minus 85 degrees, whatever that might be. So that would be like 275, I guess, going in the other direction. But we usually will measure the angle that's the shortest path, and that makes sense, right? So let's go ahead and pause, and we're going to make this one our U try. And then once you tune back in, we're going to wrap up the lesson for today. So go ahead and pause the video, give this one a try. Hopefully you have a protractor and you can test this out and see what the angle measure is. So again, you probably have a little more accurate angle measure than I do if you had your protractor. And actually maybe I do have one. I'll go check it. Okay, so I can confirm I did just get my protractor, and it was almost right on the nose, 70 degrees, and then of course going in the clockwise direction. So how you can tell the direction is, as I would really encourage you to do this, where you just take the little arrow and start on the side of the angle that has your original point, and then draw the little arrow going towards the other point, and that just shows you the order that it's going. So it's clearly going this way around like that, right? I mean, not quite, but it's starting here and going this way like that. So that's clockwise. So that does it for today, and I'll see you in class.